were just talking about the fact that, Weston, we were just talking about the fact that we know how many electrons we're going to have because of the fact that it has to equal the number of protons. So we can put 2 electrons in our first shell. And how many can we put in our next orbital or shell? Does anyone know? You can have 8. You can have up to 8 in the next one. But are we going to put 8 in there? No, we're only going to put 3 in there because that's all we have for our next one. I got to remember which one was my next shell, though. That's my craziness. We'll just do this one. So we're going to have our 3 electrons in there. So some simple facts about the atomic theory that you guys need to understand. Some simple facts about the atomic theory that you guys are going to need to understand are that, for instance, that the number of protons always in an element, so in an element in its natural state, the number of protons equals what? Not the number of neutrons, equals the number of electrons in its natural state. Now, when we start talking about bonding, and not bondage, but bonding, when we start talking about bonding in here, we're going to talk about covalent and ionic bonding in here. We're going to talk about how male-female relationships are similar to covalent and ionic bonding in here. But when we talk about that, that's when we start to talk about atoms losing electrons. Okay? The number of protons always equals the number of electrons. Now, if you add, so the number of protons, what else is a fun fact about the number of protons?
Isn't it like a minus the atomic number equals the atomic number of neutrons?
Oh, you're all kind of there. So the number of protons plus the number of neutrons equals the atomic mass. Electrons weigh so very little that they don't equate into the atomic mass. So when you look at your periodic table, the atomic mass will have they'll have a decimal point and then there's all these little numbers after it. Those little numbers are what the electrons kind of are. So the number of protons equals the number of electrons. The number of protons plus the number of neutrons equals the atomic mass. And Dylan alluded to it, and so did Brody over here, in that the number of protons also equals what?
No, just did that one.
Thank you, McKenna. Equals the atomic number. So when you look at a periodic table, there's always a number by each element. That number is telling you how many protons there are in that specific instance. So it's telling you how many protons there are in that element. Okay? Those are some things that if you can keep those in your head, you will go very far in chemistry. Okay? Now I also want you to think about this. So all of this stuff, this atomic number jazzy stuff, and the mass, and the neutrons and electrons, that was all discovered in the early 1800s, before microscopes. Well, there were some microscopes around as they were developing it. Before computers, sometimes even before electricity, we were able to figure out that the smallest unit had these positive and negatives in it. And some crazy scientist was able to figure out how to lay it all out on a periodic table. And it's to me, like I said, I think it's like the coolest shizzazz ever, because you cannot imagine why that is, or how that all came about as far as the atomic theory. Now, we briefly touched on the shells of the number of electrons in the shells. There are some crazy specific orders about how many electrons are allowed in each level. get into that in here. I'm not going to talk about it right now, but just know that in the first shell, or the first level, there's 2, and then after that, there's 8. But then there's this craziness because there's more than one shell and an energy level and all that stuff. But just think of 2 and 8, yeah, 2, 18, 2, 8, 18, and then 32.
Wait,
but I'm going to explain that at a different time. Yes.
How did they figure that out?
They figured it out. They just used their brains and did some experimentation and were able to just figure it out. The electron stuff we're still figuring that out, so that's why we call them electron clouds now versus orbitals versus shells versus all those kinds of things, or levels. So one last thing about elements, and then there's one last thing about elements today. So elements are abbreviated on the periodic table, right? They're abbreviated in scientific shorthand. So they're abbreviated in scientific shorthand, and it's usually their scientific name. So for instance, iron is Fe because iron in Latin is actually ferrous. So that's what those letters represent. So they're abbreviated in scientific shorthand. Usually it's the first 1 or 2 letters of either its common name or its Latin name. Okay?
Why don't they just keep that in one or the other?
Because we are Americans and we think that everything should be in our language. And Latin is actually a universal language of science. So that would be why. First 2 letters of common or Latin name. Not always. It's the first. It's 1 or 2. First 1 or 2 letters. There's a few that have 3, but those are the radioactive elements that are located at the bottom of the periodic table that have 2 or 3 in them. So that makes life a little bit different. Okay. So we're going to finish up today. I'm going to pass out a single reading sheet for you. Page 42 is what the page number is on it. And what you're going to do is you're going to read it, which is kind of a review of what we already talked about in class. And you're going to write a 1-sentence summary of this sheet of paper. So how many sentences, Mason, are you going to write? 1-sentence summary. And it will be in your notebook before you turn your notebooks in on Tuesday. So that's the first thing I'm going to give you. And you guys are going to have 5 minutes to do that in, as long as you can keep your mouths quiet while I give you the second half of this. The second thing I'm going to give you today is this periodic table Webquest. The periodic table Webquest is due on February 20th. You are going to have to do this completely outside of class time. It is on the computer. So you're going to log into a website. It's an elementary website that talks about the atoms. At the very top of the website, there's some tabs. You need to go through all of those tabs, read them, and then there's a 39-question, multiple-choice question quiz at the end of it. When you take that quiz, you're going to put your name on the quiz, you're going to take the quiz, and then you have to print it out. So whatever computer you use, you need to make sure that you have printing capability so that you can print out that sheet. Because that sheet is what you're going to turn into me on February 20th, which is next week, Wednesday. Okay? Questions?
Is that test was worth it?
You'll have to wait and see. Okay? So, any questions? Nobody has questions? I'm going to hand out these sheets of paper. If you ask me for questions, what I'm going to tell you?
Figure it out.
Figure it out. All right. Agriculture.